Hello, this is Mrs. Ross, and this is 3.6. We are continuing with our parent functions. So we did linear, reciprocal, and absolute value. Now we're going to add our power functions, root, exponential, and logarithmic functions. So this is just a lot of information and not an awful lot of problems to do. But you'll want to keep this copy so that you can use it on quick checks and the test and all of that stuff. So let's go ahead and get started. So a power function is when we have, there we go, is when we have like y is equal to x squared, or y is equal to x cubed, and it's different for even exponents and odd exponents. So here we have the even exponents, and it has domain, range, increasing, decreasing, all the stuff we've been talking about, x and y intercept, even, odd, continuous, discontinuous, etc., and behavior. And this is what it looks like if it has an even exponent, like not this, but y equals x to the fourth, that kind of thing. All right, if it has an odd exponent, like 3 or 5, etc., so an odd degree, these are the domain and range. These are the increasing, decreasing, and constant intervals, x and y intercept, even, odd, continuous, asymptotes, and then in behavior. And you can see it's a very different graph. So when it's even, it's symmetric about the y-axis, but when it's odd, it's symmetric about the origin. Okay, and then root functions. Root functions are just like when you take a square root or a cubed root. And again, we have a different graph for even roots. So square root or a fourth root or something gross like that. So for even roots, the graph is going to look like this: domain and range, and increasing, decreasing, constant, x, y. Even, odd, it's neither because it's not symmetric, continuous, asymptotes, etc. So I'm not going to read through those because you can read them. And then for like an odd root, so if I have like a cube root or a fifth root, very different graph. And you can see this is for an even root, this is for an odd root. Domain and range, all the intervals, intercepts, etc. Okay, exponential functions where b, that's this, is greater than 1. So we have like 2 to the x or 50 to the x or what have you. It's greater than 1. Okay, this is exponent greater than 1. It should be the base is greater than 1. This should say base. Okay, so if the base is greater than 1, this is what our graph looks like. Okay, we've got our domain and our range, our intervals, intercepts, even, odd, continuous, etc. Okay, now if our base is between 0 and 1, meaning like if the base is like 1/2 to the x or 3/4 to the x or something gross like that, then our graph changes. So this is if it's greater than 1, and you can see it flips when it's in between 0 and 1. And we're not even talking about negatives. So domain and range, the intervals, intercepts, etc., it's all right there. You can read it. Okay. Logarithmic functions. So this is where we have the log base something of a number. Logarithmic functions with a base greater than 1. So that's this. So normally your log, if you have like log x, your base is normally 10. But you can have log base 3 of x or log base 8 of x. It's not unheard of. So if the base is greater than 1, this is what the graph looks like. These are the domain, intervals, etc. And then if the base is between 0 and 1, so if I have log 0.5 of x or log 0.75 of x, that is so disgusting. This is going to be the graph. So you can see it flips it when you get less than 1. It also messes with the domain and range and all the other different characteristics of the parent function, which is just the logarithmic function. Okay, here's the activity, and this has a lot of writing. So you may want to get a sheet of paper because I'm going to have to, I'll have to erase and come back and all of that stuff. So it says use the following types of functions covered in this lesson to answer the questions, and it lists all of the types of functions that we have here. So what I did was it says, which of the functions are odd? So I went through and I looked at the characteristics. Like, let's see, this is neither, so I won't list that one. Also neither, neither, neither. Odd, so this one is odd. So root functions with odd roots is odd. That's one of the ones I'm going to list. So let's see. So number one, so odd, just as a reminder, is symmetric about the origin. Okay, so an odd degree power function, like x cubed, or an odd index root function. Okay, so like a cube root. Okay, those are the two odds that we have. Let me change colors. Continuous. Okay, so number two is continuous, and all of the functions in this lesson are continuous. All of the power, root, exponential, and log functions, no matter what the constraint is, if it's greater or less than 0 or 1 or whatever. Okay. And then, let's see, vertical asymptote. Which functions have a vertical asymptote? So that's 3. The log functions, both of the types of log functions, the logarithmic with b greater than 1 and logarithmic between 0 and 1, have a vertical asymptote at x equals 0. And you can look back at the graphs and see that. And then the last one here has a lot of writing, unfortunately. Which of the functions have an increasing section anywhere on their domain? Okay, that means it's increasing anywhere on their domain. So let's see. So I have the even degree power function. So like x squared, x to the 4th. I have even degree root function. So you have your square root or your 4th root. Okay, these are increasing on 0 to infinity. Okay, I'm going to erase this and keep writing, so you might want a sheet of paper. Okay, I'm going to come up here because I'm not done with number 4. So I have odd degree power function. So that's like x cubed. I have odd index, I don't know why they don't call it degree, root function. So that's like cube root. And I have exponential function with b is greater than 1. These are all increasing from negative infinity to positive infinity. Okay? And then the last one I have, I'll put it down here, just one more, log function with b is greater than 1 is increasing from 0 to infinity. And that's it. Let me know if you have any questions.